Next example, slightly harder. I have a cluster of series parallel with one single 4, and then that parallel cluster is in series with these 3 resistances. So again, just like before, I'm going to start with my parallel cluster, which will have, this is 8. So I will have 1 over 4 plus 1 over 8, 2 plus 1 over 8, 3 over 8. And again, that is 1 over R equivalent. Then you flip and you get 8 over 3 would be the R equivalent for your parallel cluster. Parallel cluster is then in series with everything else. 6 plus 3 plus 1 is 10. So it's going to be 10 plus 8 over 3 will be your R equivalent for the entire circuit. If you take 9 and you divide it by 38 over 3, you're going to have 27 over 38 of amps. That's your total current. So that's 0.711. This takes 0.711, 0.711 amps here, and 0.711 amps here. Now the parallel cluster, this resistance is twice the resistance of 4. So a shortcut could be, you know that since this is, so then the shortcut could be that you have 2/3 of the current go here and only 1/3 of the current to go here. So if I take 0.711 and divide by 3, 0.37, and double that is 0.474. So if I add those two, that is how I get 0.711. If, however, the ratio does not make sense to you, you can go the classical way. You take your voltages together. So 3 times 0.711 gets me 213. So this will be 213 volts. Double of that is going to be 426 volts. And then 0.711 volts on this one. Then if I take all of that from 9, I get a voltage of 1.899. And then I take that 1.899 and I divide it by 8. And then if I take it and divide it by 4, the same 1.899 divided by 4 is going to give me double of that, 0.474. So that's how you figure it out. So I got 0.237, which is 1.899 over 8. And then 0.474, which is found as 1.899 over 4. So that would be the current going through each one of those. And as far as voltage on each one of these in series, you will take 0.237 times 6, so 1.42 volts for this guy, left for the other one, right? And then you can do 1.899 minus 1.42 for the remaining voltage, or you can just do your 0.237 times 2, and that is your 0.474 volts right here.